What's up, guys? Today we'll be doing lesson 9.6, and 9.6 is about symmetry and rotational symmetry. Now, symmetry is if, for example, we have like a line of symmetry. So you have an object, a picture, whatever, and you cut it vertically, horizontally, diagonally. You have the same image on both sides. They are perfectly symmetrical. So let's go over a few examples real quick. So here we go. 3 examples. How many lines of symmetry does the figure have, or each one? This is a rectangle. And if I had a ruler, I could do this perfect. We have one right here. I know that's not straight, take it easy, guys. And both of those would be equal. So that's 1. We also have one going horizontally, which makes it 2. So this has 2 lines of symmetry. Now here, we start to look. Obviously we can go straight down, that works. I'm going to erase that because it gets in the way. Now what happens if we went from here to here? Yeah, that looks good. That's 1. And if you went here to here, yes. And then we already set the one that goes straight up and down. There's another one that goes from here to here, and one that goes from here to here. This is a regular pentagon, so which means that it's not chueque, it's not squished in, nothing like that. You see over here, this is a pentagon also. Besides squished, it's squished in right here. So this is off. This is a regular one. So in a regular hexagon, you have 6 lines of symmetry. In a regular octagon, you have 8, and so forth. So this has 5. Over here, this is chueque. It's not going to work, watch. We start from here to here. It doesn't work because it doesn't look right here compared to this side. So that didn't work. And you could test it on the other ones, but it doesn't work. All we have is this one. Just one line of symmetry. Now, I can't draw perfectly, so I'm going to show you the key that has all of these broken down exactly in nice straight lines. So hold up. Here we go. So here's the rectangle that has the vertical and horizontal, which makes the 2. Here's the 5, perfectly, better than mine. And here's the 1 for this chueque, squished in pentagon. That's symmetry. Symmetry isn't very difficult. We're just seeing if we can cut things in half, left, right, diagonal, and see if we get the same picture on both sides. It's the rotational geometry. The rotational symmetry, which is new. So, rotational symmetry. The easiest way to explain it is, well, to look at the 2 words. We're going to have a picture, an object, a diagram, whatever, and we are going to rotate it. So we're going to rotate it first, and we're going to compare it to the original. If it's symmetrical, then we're going to call it, or then we're going to say it has rotational symmetry. Now remember, you can rotate 90 counterclockwise. You can rotate 180 counterclockwise. Now you can also do 270 and 360, but if it's 90, it's also 270 by default. And if it's 180, then it's already 360 by default. So we don't worry about these. We're just going to worry about 90 and 180. And we're not going to put counterclockwise because it's implied. We're just going to do 90 and 180. And it's easier if I show you on Microsoft Word so I can rotate stuff. So let me go over there. Hold on. Now if you notice, we're here on Word now. I have 3 kites right next to each other. I'm going to call this first one my base kite, my regular one. So I'm not going to do anything to it. This is my regular one. I'm going to compare everything to this regular kite. So I'm going to come over here to this shape, and I'm going to rotate it 90 degrees counterclockwise. So I'm going to come over here, 90 degrees. Then I'm going to come over here to this one. Not here, that's 90. I want to come over here to 180. And we're going to take a look. Maybe it's symmetrical, maybe it's not. So let's first try it. So hold on. So I'm going to get this green little dot and I'm going to rotate it 90 degrees counterclockwise. So here you go. There you go. This is now 90 degrees counterclockwise. And if you look at your picture, is this picture right here symmetrical to this one? Are they like the same picture? We can cut them in half. That one and this one? No, they're not. So this was 90 degrees rotated, and it's not symmetrical. So 90 doesn't work. Now I'm going to get this picture. I want to rotate it 180. So I'm going to grab the green little dot. I'm going to go this way. That makes 90. I need to go again. Another 90, and there is my 180. Oh, almost. It's a little twick. There we go. This is 180. It's turned all the way upside down. Now, is this picture here symmetrical to this one? Nope. Because the shorter points on top of here, the kite over here is regular and the kite over here is upside down pretty much. That's the easiest way to explain it. So here's 180 degrees, and this is also not symmetrical. So you would say for my kite has no rotational symmetry. But does a kite have symmetry? Yeah, right here. Both sides are the same. So this kite is symmetrical, but it doesn't have rotational symmetry. Sounds like a good test question. If I ask, if an object is symmetrical, does it mean that it has to have rotational symmetry? No. Anyways. Alright, so I'm back here on Word. I'm going to do a new example. As you can see, I have three shapes that look like, I guess you want to call them hourglasses. I'm going to do the same thing we did before. I'm going to call this one my regular. And I'm going to do 90 degrees here. I'm going to do 180 on this one. And yeah, this one has a line of symmetry there and a line of symmetry here. Even though it's not asking for it, just put it there just so you all see it. So let's see over here. Alright, so here's the 90 degrees. So we're going to grab it here and we're going to rotate 90 degrees counterclockwise, which is right there. Now, these two shapes are now totally different. This is like a time glass, or an hourglass, sorry, an hourglass that's up and down. This is like a bow tie, or your hourglass on sideways. These two have nothing alike. This symmetry here, when you cut it up and down, is two triangles left and right. Here, when you cut it, the triangles are up and down, so nothing. So, no rotational symmetry. No rotational symmetry for 90 degrees. Now the 180. We grab the 180 and we go 90 right there and keep on going to another 90, which makes the 180 right there. This 180 looks a whole lot like this one over here. So yeah, when you cut it here and there, they have the same exact symmetry. This here, when you cut it in half and sideways, looks exactly like this one. Two triangles the other direction, everything's good to go. So 180 degrees, yes, there is rotational symmetry. How would you answer it? at 180 degrees, there is rotational symmetry. Now, so I've talked about, well, I'm going to call this RS, rotational symmetry. So I've talked about no rotational symmetry, and I've talked about 180 degrees rotational symmetry. Can you have 90 degrees rotational symmetry? Yeah, of course you can. Can you have both? Yes, you can. Depends on the shape. Now, when you get your work, you don't have a little green button where you can flip around stuff like on Microsoft Word, but you can be a little, smart about it. And so when you get your paper, it's like a rectangle. That's the side going up. Well, I would turn it sideways. I'm sure most of you do this anyways, or you can do it in your head, and that would give you 90 degrees. And then I would flip it over, or not flip it over, flip it upside down, and that would give me 180 degrees. Now, that's pretty much it. I'm just giving you a little bit of shortcuts what I would do if I were a student. Alright guys, laters. Thanks for watching the video. I'll see you in class.